Welcome back to part 5. We're going to start putting some of this stuff back together. I already started installing some of the trimmers in the back, and I went ahead and put this block capacitor back in. What I was going to start doing is start wiring the power supply and the transformer back up to the places it needs to go. One of the things, actually two of the things that I do when I work on the radios is I'll put a polarized plug on it and also put a fuse in it. So if you look at the schematic of the power supply, as you can see, I've made a note there where I'm going to put the fuse. Now that particular lead where the fuse is at prior to the on-off switch number 31 is going to be the positive side of that cord or so, and then the other one will be the neutral side. That way the fuse is prior to anything in the circuit, period. So that's what we're going to do. Coming back, the power cord comes in a grommet here, which I think I've got some rubber grommets. I may replace that. I don't know. It seems to be in pretty good shape. So I was going to put the fuse there, but it's awful crowded there. So I went ahead and put some of the other stuff in, and it appears that right here, this is the bottom of the screw that holds the transformer on. So I'm thinking that maybe I'll scruff this up a little bit here, take this screw out, put some epoxy on the back of this, and then screw that in place. Then the lead will come in, the negative will come to this capacitor here, which the one side of the primary will come to, and then the other lead, the positive lead, will come to the fuse block itself, and then from there it'll go to the on-off switch, which I haven't put in just yet. But that's, I think, looking at all my prior photos, this is, I may tilt it a little bit like that, but should have plenty of real estate in the bottom there. Let's do that and see how that's going to turn out. I've roughed up the surface, and I roughed the bottom of this up. So we're going to put a little bit of epoxy. I'm using the Gorilla epoxy, and so far I'm not really impressed with it. But it should hold. Anyway, I've got the screw backed out just slightly. So let's see if we can get this started. Somehow or the other I hit that first time. So the epoxy should hold it, but the screw should hold it also without a clamp. So sometimes I do this without gloves, and of course now all you can see is my hand. All right. Now let's let that set up, and then we can wire it. We've let that set up a little bit, and so I'm going to show you the switch and the potentiometer. Well, we'll call it potentiometer. It actually goes in the circuit in the very beginning on the antenna. In the early radios, they used it on the front end to reduce the resistance on the antenna, and thus reducing the signal coming in, and that's how they used for the volume control. the switch itself was not working. So in order to get to it, you had to bend these tabs here. I'm always afraid to bend these things because they're bad to break. But took care with them and bent it and took it and sprayed it with some deoxit. Sprayed the switch also. Cleaned the potentiometer out and sprayed it also. And then when I went back to bend that, I took a tip from Michael from That Tube Sound that his wife had passed along since she was working with jewelry and what have you, and said if you use a wooden dowel or a piece of wood or something to bend that instead of a pair of pliers or anything like that, it runs less chance to break. So seemed to work. It's now secure. So let me stick this in there and then we'll start connecting it. Here's something that I felt like may be important to pass along. It doesn't have a stop on it. You know, a lot of them will have like a tab that goes through the chassis or something to keep it from turning. What it does is this side of the potentiometer is soldered to the ground itself. One of the things that's important, feel like to mention, is there is a grommet, a fiber grommet that keeps the potentiometer from the shaft of it from grounding out here. As you can see, it goes, it's got a reset in it, and then there's another one that goes on this side that goes in that keeps it from being touching the chassis. Now, as usual, I dropped that just before I started filming. So now I've got to stop and find it. As usual, the floor monster ate the washer. I did find it after a while. But let me show you. The wiper, or the center, is connected to the shaft. That's why it cannot be grounded to chassis, because this one will be grounded to chassis, be soldered to the chassis, and then this one has to float off of it. So it has to, that's the reason for the grommet, the fiber grommet, to keep it from shorting out. So let's put that in, and as promised, I did find it. I've got the potentiometer and switch mounted. I haven't soldered the connection yet. I wanted to check the continuity to ground. I've already got it grounded. As you can see, that is the ground. Now let's check the potentiometer shaft. Yeah, because I'm touching, it's going to show in the meg range, but you can see that it is not touching the chassis. Now, if it sounds confusing, but if I go ahead and ground that, it's going to show whatever the potentiometer is reading, 11 ohms, because it's reading through the potentiometer from the shaft to ground. And if you'll see, it'll change as that's up 22K, and we'll run it back down. So that's why I didn't connect it. I wanted to make sure that the shaft itself was not. And because I'm touching that, I'm getting in the meg ohms. But just wanted to make sure that wasn't shorted to chassis. Wired the primary up. Tried to get the wires out of the way. I used the white wires according to the Philco schematic. that this particular one was the primary. Goes to the switch, and also comes over here to the C32, which is the safety cap. And so I've hooked up my ohm meter, and in theory, if I turn this on, we'll be reading the this is where the positive is going to connect, and this is where the negative is going to connect, or the neutral is going to connect. So we turn that on, we should get about 10 ohms for the primary of the transformer. So I think that's wired correctly. So we'll go on and we'll do the rectifier and the high voltage. I've got the filaments wired up to pins 1 and 4. That's the largest pins on the 80 tube, the rectifier tube. And then I went ahead and wired from pin 4 to the capacitor C34. Now, one thing to note, the cans of these capacitors, these filters, are above ground. And what that means is that the cans are not grounded to the chassis itself, so they're insulated with some fish paper, so it's not grounded to chassis. And then this resistor will take, it goes to the can side and then takes that to ground. As you can see on the schematic there, that is the resistor number 36 in the lower right hand corner. And so both of the cans are tied together, so I put that jumper in there. Now what we'll do is we'll take the center tap of the transformer and we will attach it to the cans of the capacitors, the filter capacitors, and then the high voltage will go between the number 2 and 3 on the rectifier tube. I wired the high voltage windings, or the leads, from the transformer to pins 2 and 3 of the rectifier tube. Also the center tap to the can side, or the floating side of the filter capacitors, and also tied the lead to this resistor that goes to ground. And you'll see that in the schematic. So now all we lack is wiring up the filaments to the other tubes. So let's get that done. I wired the filament to the other 3 tubes. I decided to replace that wiring. It probably was okay, but it was looking a little ratty. The color code on the schematic says this should be black with yellow trace. Of course, used yellow wire and put some black trace on there. Brought it over and went ahead and just replaced even the short jumpers here, so just to be consistent. I had just put the trimmers in. Of course, it was just one little screw. I took it out, they weren't wired or anything, so I removed those to facilitate me putting those in. So the next part is we'll put the rest of the block capacitors in, and then we'll start working on this rat's nest here and finishing it up. One thing I omitted is there, when we put the tuner on, these wires are going to come in and tie into these points right here for the pilot lamp. let's look at the antenna circuit. Here's the schematic of it. As you can see, there's a ground that on the far left, and then it connects to the volume control potentiometer, and then it ties into the antenna transformer, coil, whatever you want to call it. And you can see that from there the other side goes to the tuning condenser and also the grid cap pin, or number 4, no, I'm sorry, the grid cap on the 36 tube of the detector oscillator. Now looking back here, here is the ground itself on that coil. This is the wire. Supposed to use a pointer, sorry. This is the going to the tuning condenser. Also, don't know if you can see it or not, but that's also the connection that goes up and goes out the top of the can that goes to the grid cap of the tube. This wire here is the ground, the antenna ground itself, and then this one will go up and connect to the center of the wiper of the let's see, the wiper of the volume control, and then on the other side there'll be another one, another wire comes out and will pair up with this. There'll be the antenna going out through the hole and going out the back of the radio. Let's look at the work I just reviewed on the schematic. From the antenna coil goes up to the center of the potentiometer. Here is the antenna coming to the high side of that. It goes down and goes out with the ground itself. Here's the gimmick capacitor from this this coil. It goes on the center of the wiper. I should have, looking back, I should have probably left this wire because I left this wire, and so hopefully the gimmick is going to be similar. I put this block capacitor back in. As you can see why I left these in place. It bolted right back up, and we connected here, and then now this one will go to ground back in here. I've got to solder it, and then we can move forward with the rest of the construction of it. As I'm putting this back together, I find interesting things. So I went on the Ron Ramirez Philco forum page, and or the Philco workbench, and seen the modifications for the 80. This gimmick capacitor, and if you'll remember when we first pulled it out, the set hadn't been touched in many years, or what it appeared many years. But this is a recommendation as an enhancement. It's not in the schematic, but this is on the Philco workbench recommendation to do. Also, the capacitor and the resistor on the oscillator coil, it shows the modification. So that has been modified, but you saw how old, or it appeared that old. Let's take a look at the oscillator coil. This particular wire here will go to pin 4 on the oscillator detector tube down in here. This will go to C7, which is in this spot right here, and this one will go to C12, which is over here. As you can see on the schematic, the connections on the C7 and C12 is on the oscillator coil, which is listed as part 8. And if you look right here in the circled area, there's a 10K resistor and a 750 microfarad capacitor, and that is at the top of this can here. And we saw that, I believe I showed you in the first video up in there, but that's up in there. So this should take care of the oscillator coil connections. Now, one of the things that we will have to do, and you guys will remind me a little later, I hope, is we've got to also, even though we're getting the coils reconnected, we're going to have to go back to these tube sockets and make sure that each one of these pins are connected to where they need to be, especially with the block, bakelite blocks. I haven't put these two in yet, simply because I'm wanting the area to work in. So let's get these connected here. And if you'll notice down in here, there's really nothing connected to these tubes. This tube, the detector oscillator tube at this point in time. So we're going to have to come back and make sure that we get that taken care of. Now, a quick note, if you'll notice these wires on this particular, this is the IF coil transformer, what have you. I did not change the wires on it. The wires were in pretty good shape. They were a little dirty, but getting up in here, when I pulled that out, it was very, very brittle. Not brittle, but the wires are very fine. So I did not want to risk destroying this coil. So I'm leaving these in place unless they run into such a problem that I'm going to have to do something with. But right now, I chose not to replace these wires. Also, in the modifications on that website, it says to replace this 4 meg resistor with 2 meg. Well, I went and double checked it, and it was up to 8 meg. So I went back and I took 2 1 meg resistors and put them in series, and now I've got 2 meg across there. Put a little liquid tape on there. Shouldn't touch anything, but just for safety's sake, I put some on there. Now, the schematic shows a 50 picofarad capacitor here. I have read in Antique Radio Forum about it missing in other sets, and there was some debate. It says it can't work without it. Apparently, it came without it. The 84, which uses a 77 tube, does not have it. And so, I don't know. I've written an email to Ron Ramirez about this capacitor. So, if I find out anything before we publish this, then we will. I'll update you on that. When I went to put this or wire this IF transformer in, I decided to go ahead and change some of the wires out, and some of them I didn't. It was they just looked a little fragile, and I didn't want to mess with the small wires up inside there. So let's look at how it's in the circuit. Here's the schematic, and if you'll see the numbers, this is how I numbered them. That doesn't mean that's the way they are, clockwise, counterclockwise, or anything like that. I just identified the wires and how they fell in the circuit, and that's how I'm going to put them back. So if you'll look in the upper left-hand corner, you'll see number 2. It's top of the primary of that coil, and it goes to the trimmer 7 and also the grid of the first, the detector oscillator tube, which is pin 2 on that particular tube. Then if you'll go clockwise, you'll see number 3, and that is the top part of the secondary, and it goes to number 17, the trimmer. If you'll see just below down that line, number 17, and it's also goes through the 4 meg resistor to the green wire coming out the top on the grid, for the grid of the second detector tube. So the 17 side, the bottom side of 17 is to ground, so that's where that goes. Now if you look down to number 4, it goes to the back side of number 18, and then number 5, it goes down, and that actually goes to the B plus. So let's see how it really looks in the circuit. Okay, number 1 is to ground, and so this is the ground. It'll come up to this part of this capacitor, and it'll continue on to the next tube to ground that tube. Number 2, right here, it goes down to the plate of the tube, and then it continues on to that number 7 we talked about. Then let's see, what is this? This is number 5, so it goes on and goes up to this capacitor here, which takes the B plus from here and goes to here, and then onto this tube. Then you've got number, let's see, that's not even in that circuit. Then your number 3, that goes to number 17. That's that part of number 17. It goes to here, to the trimmer. And then number 4 itself, that will go to the back side of number 18, the trimmer here. So let me put those in. Let me show you the schematic again, so you can get a look at what we're doing, and then let's solder this stuff in. I think I've got it wired back together. I want to go through it one more time and check all the tube sockets and trace out the circuits to make sure I've got it as per the schematic. I put in a power cord, UL knot. Of course, I got my fuse. I've wired the speaker. Let's flip it over and show you the top. Got the grid caps on. Of course, there's the speaker wired in. Of course, it'll be on this side in the cabinet. But now I've got to clean up the tubes. If you'll remember, I haven't even checked the tubes, to tell you the truth. So what I got to do is take the tubes, clean those up a little bit, and test those. And the 42 tube, if you'll remember, was the globe-shaped one. I'm really anxious to see if that tube is good. It really would be cool to have an original like tube in this radio. Let me clean those up and check them out, and then we'll apply some power maybe a little later. I cleaned up the tubes and tested them. Had to buy one because one was missing, but the tubes all check good. And look at the globe number 42. I'm really proud of that. Tested really high too. So I do not have the rectifier in. I'm just going to bring it up and see if we get filament voltages. There's about 100 volts or so. There's about 117 volts. Got a dial light. Tubes are lit. So let's bring it up and put the rectifier in and see what happens. Check the high voltages. There's the voltage for the rectifier tube. Should be around 5 volts. There's no tube in there. Okay, this is for the other tube. Should be around 6.3 or so. So filament voltage looking good. I've got the meter set DC voltage. I've got it hooked up to the plate of the output tube. And we should see something on the order of 240. Let's bring it up and see what we've got. Started at 0. Well, maybe you can see the, yeah, I think you can see the meter itself. We'll bring it up to about 30. Leave it for a few seconds or so. Just some indication of current. It's going up to about 50 to 60 or so. Starting to see a little DC voltage on the plate. Just a little bit less than 200 milliamps. This being 46 watts. So I'm looking anywhere from 400 to 500 milliamps. That sound about right. We got 103. We're looking for, on this, is about 240-ish, somewhere thereabouts. Let's go to about 75. Let's turn the volume up. I don't hear anything. Still got the cover on the speaker. Maybe we'll get lucky and hear something. I don't know. It's going up to about 100 volts. We're looking at just a little bit over 300 milliamps. And I hear a little bit of static, I believe. I don't see no smoke. We're setting about 200 and settling out about 220. It's going up to about 100 or 115 volts or so. So we're looking at about 200. Well, it's going to settle back. So it looks like the B plus is looking okay. I do hear some static. Well, what about that? About 243 volts. And we have sound. Excellent. Current is about 450 milliamps. That looks about right. I'm sure we need an alignment. Wow. Yeah, it's going to need some alignment. All right. Definitely going to need an alignment. It's about 8 p.m. at night, and so you can hear some distant stations. This is the local station here. It's a little bit distorted, so I think that it'll be with an alignment it'll be a lot better. The low end doesn't seem to be that active, so I think that's an alignment issue there. At least we got sound. That's a start. Voltages look good. I went through the rest of them, and they're all good. A little distorted. but that looks pretty good. All right, we're going to wind this up. The next time we'll do an alignment and start working on this cabinet a little bit. But give you another angle of it. I think that cleaned up pretty good myself. So until next time, from Larry from the hills of Tennessee, thanks for watching.